So, hello everyone. Sorry to be late a little bit. Welcome to EuroPython 2012. So, it's my pleasure to introduce you to the talk for Tornado. I will not indulge in presentation and leave the word to the speaker so you can enjoy the technical part. Thanks.
Thank you. Good morning. Thank you for coming so early, despite the good coffee downstairs. But I'm Oscar Vilaplana. I am originally from Catalonia. I moved to Netherlands to do cool things with Python. One of the cool things we built involved Tornado, and since I learned how it worked, more or less, I thought I might as well share it. So, how many of you have used Tornado before? How many of you have read the source of Tornado? Okay. I think there will be maybe some interesting questions. So, as the song says, it all began with a god named Thor. And there were lots of tempests and thunders. And then the word thunder in Latin languages evolved to many similar languages. In particular, in my language, it's called tro. And when it thunders, the verb for thunder is truna. And when there's a lot of thunder, we call it una trunada. So that's one thing. That's a similar verb. In Italian, it's tornare. In my language, it's torna. And when you return, the returning of somebody is tornada. But we also use this word for the refrain of a song. So, the song goes somewhere and sings some things, and then it does the refrain. And then it goes somewhere and sings other things, and then it does the refrain again. So this is similar to the I.O. loop. You can schedule some timeout and some callbacks, and you can do your stuff, but you can trust that the refrain will come. So from Trunada, the thunder and the power, and the trusty refrain that always comes the word Tornado. So, what is Tornado? It's a non-blocking web server. It uses EPOL or KQ, depending on when you run it, to check if there's something to be done in some socket. It handles thousands of connections. It was written by the guys at Facebook to power their friend feed. So, what do I use it for at PayLogic? Why do I even care? Why do I even go and read the source of Tornado? Well, it's nice to know what you use, so know how it works. In particular, I was writing a quite critical system with Tornado, so if I didn't know what it was doing, how could I trust it and go to my boss and say, please believe me that this will really work? Of course, that doesn't mean you should read the source of everything you use, because sometimes it's impractical, it's just too much. But if the source is readable, I think you should read it. And finally, it's fun to read, and it's fun to share with people. So what did we use it for at PayLogic? So we built a scalable and distributed and fail-tolerant high-load thing. Unfortunately, I cannot tell you which thing. I can only tell you it was really cool, but it's a secret. There's, however, a way around this secret. If you work for us, I can just show you the code. So we are looking for really good Python developers and architects. So if you're one of them and you would like to move to the north of the Netherlands, please write me. Anyway, Tornado. What is Tornado made of? Well, it has an I.O. loop, which is like everybody's building their own I.O. loop these days. So it has callbacks and tasks and timeouts. We'll look at all of these in depth. It has a TCP server, which is what handles the connections with the internet. Some application class that you can extend to make your own application, so you can just instantiate. It has a request handler that parses the requests of the users, and it has some generators for you to write cool stuff without having to set callbacks everywhere. But what if you don't care? What if you just want to write some TCP server that, I don't know, that returns uppercase letters? Well, you can just take a part and extend it. You don't need to use the whole thing. For example, how would we write a very simple TCP server? Let's see the code. So, this is how I would write it. This is just returns uppercase things. Well, I take the TCP server of Tornado, and I extend it. I need to implement this handle stream. Like when there's a stream, what do? Well, I read a line from it. What do you mean to read a line? Well, I mean read until there's a \n. And when you're done, please call this callback. Handle read. And handle read, well, just write it back into the stream, uppercased. As you can see, it's really to the point. And this is non-blocking. So this is all you would have to write this very simple TCP server. This, by the way, how I will do everything. I'll show you a little example, and then I will explain how Tornado works, and then I will show you the code of Tornado. Sometimes it's a bit complicated. I'll try to make everything clear. In some small cases, I removed the complicated and not important parts of the code to make it easier to understand. But you can ask questions later, and we can look at the real source. OK. So let's get started. How do we make a simple app? Well, it's very easy. You need to define a request handler that will handle the request for a certain URL. You need to implement at least, I don't know, get or post or whatever method you want to support. Then you define an application, and then you tell it to listen to a certain port. And then at the end, you start the I/O loop that will make everything work. OK, what do I mean by that? Here's the simplest application. As I said, I define a request handler, main handler, I implement get, I just write hello world into the browser. I define the application, I just tell, well, the slash is handled by the main handler. And at the end, I just tell the application to listen, and I start the I/O loop. I will not run the examples because, well, you can imagine, I would go to the browser and I would say hello world. So let's just keep to the business. So what is an application? As you saw, mostly it's just a collection of request handlers. You tell for this URL, please use this request handler. You can use, of course, regexes for the URLs. And the application implements listen, which just starts an HTTP server, sorry. And the HTTP server needs a callback. Like when there's a connection, who do I call? Well, the application sets itself as the callback. So this means it has to implement call. And the underscore call of the application is what actually handles the user requests. Let's check what listen does. It's very small. Oh, it's too big. I'll make the font a bit smaller. Maybe 19 or something. It will have to do well. Most of the code is just documentation, so it's quite nicely documented. This is all the code. As you can see, mostly initiating some properties, and then we start TCP server. The I/O loop, you can pass an I/O loop. Normally, you don't pass any I/O loop because there's only one I/O loop per process. So, which I/O loop is it? Well, the one of the process, and yeah, that's it. Handle stream when there's a stream. This stream is handled by the HTTP connection, which we will look at later together with the IOStream. OK. So what does application _call do? So when there's a connection in the socket, we call this guy. Well, the I/O loop will call this guy. What does this guy do? Well, it passes the URL, and it decides which handler to use. As we said, that an application has a collection of handlers tied to URLs, so that is how it can know which handle to use. It creates an instance of it. Each connection gets one. So you can store things in the state in the handler, the instance of the handler. Then you can store the state of this connection, and then it calls underscore execute on it, and it passes something called transform, which is used to compress the connection or to do any other transform you want to do. Let's look at the source. Okay, and it looks very big, but it's actually quite simple. So, the transforms I said, gzip or whatever, we can forget about the transforms, it's not important. So, cache host handlers, why is this here? Because you can define handlers for every host name. So it tries to do that, but maybe you're not using that. Maybe you just have a bunch of host names and they are all handled by the same Tornado application as if they were the same host. So if it cannot find it, it says, well, just use the default host. I don't care. Okay. Then here we have some handlers. So then for every handler, it tries to match. Does it match with the does the regex in the URL match the URL that I have from the client? If it does, well, that's our handler. We just need to instantiate it. And then here you have something, because maybe you have groups in the regex of the URL that have names, so it needs to do some working on that. It needs to uncode them. Maybe some of them are optional. So all this is just getting the parameters from the URL in all possible cases. So you can forget about that for now. If you didn't find a handler, well, that's a 404. But the main thing is this line here, just take the handler class and instantiate it. Okay, we have a handler then, otherwise we would have a 404. And then we call execute on it, as I said, passing those transforms and arguments from the URL. If you set there's a nice debug setting that automatically reloads the code if you modify it, and also it doesn't use the cache of the template. So if you change the template, you just see the change immediately. But as you see, I was not lying when I said that. That call parses URL, picks the handler and instantiates it, and executes it. Okay. But what does request handler underscore execute do? When do we get to see the actual business of the thing? This guy is this guy is really going to execute the request. It needs to know if it's a get or a post. It will check which method you're using, and then it will call the appropriate method. So maybe it will call get. It checks the cross-site request forgery cookies, and maybe it closes the connection. We will see when and why. Okay, let's look at the, let's look at the source. Execute. This is all. Transforms, we forgot about transforms. If the method is not supported, well, there's an error. It checks the cross-site request forgery cookie, forget about that. It calls prepare. Prepare is a method you can define to prepare for it, like I want to initialize some database connection and I'm going to do some work before I actually do the get or the post. Then, if we're not finished yet, for example, prepare just raises a 404. Well, then we're done. But if we're not done, then we continue. We get the arguments, and then request.method, which is get or post or whatever. It does a getter on it, so now from self we get the method get or post, and then we execute it, passing it the arguments and the named arguments from the URL. And this is the maybe. If auto finish is true and it's not finished yet, then finish it. So if you don't want the connection to be finished for some reason, you just set auto finish to false, and it will not be finished for you. Of course, you underscore, so you don't really need to do it by hand. There's other nicer ways. Are you still following me? Or are we already lost? Good? Okay, nice to know. Thank you. Okay, so let's look at the IO loop, because it seems to be the busy guy in this deal. And let's look at the callbacks, timeouts, and events, because we need to understand those before we can understand more of the IO loop. What is the IO loop? Is the core of Tornado? Well, I don't know. It's a bit of a vague sentence. You can use it standalone. You can use it with WCI. It's used for server and for the client. So there's also an HTTP client, part of Tornado. You can use it for testing or for doing some proxy-like thing. Or there's a single instance in each process. So if you want more instances, get more processes. And it's very small. So it's quite easy to go and read exactly what it does. What does it do? Well, it loops forever, like the song I was saying before. And it executes callbacks as soon as possible, timeouts when they are due, and events. It handles events when occur. So if I say, please call this method when there's a connection, well, when there's a connection, he will call this method. So what is an event? It's something that happened on a socket. Actually, it's something that happened on a file descriptor. You can maybe look at a file. For example, if a user opens a connection, and applications define handles for those events, like when there's a connection on the socket, please call my _call method. But you can define your own methods, your own handlers. So okay, how does Tornado wait for an event? What exactly does it do when it says, please, when there's a connection, call the application _call? What happens? Well, it calls a handler, and it passes a file descriptor, a handler, which is the _call, and then the events that it wants to listen to. For example, read or write or error. There's other methods, a base handler, like before I was listening to something, so now I also want to listen to these other things. Or I don't want to listen to read anymore, I just care about error. And remove handler is just don't notify me anymore for this file descriptor and I am this handler. Okay, so how does the IO loop work? We will get to the source very soon, but before we go to the source, what exactly does the IO loop do in 4 steps? First, as we said, we process the callbacks. Those callbacks were scheduled by previous callbacks or event handlers. So the first thing it does is process callbacks, which is a bit funny when you read the source first time. What callbacks? What do you mean? And they put a little comment, but it's surprising. After this, we process the timeouts. So for each timeout, this is wrong. For each timeout, if it's due now, then run the callback for it, not schedule, it's run. And then it calculates the time until the next timeout, and we will see why. So I run all the callbacks that are due now, and if the next callback, the first that I have to run, will be in 30 minutes, then I keep this 30 minutes value, because maybe I need it. Then third step, the events, as we said, there's a poll timeout. So we're going to poll for events. We're going to block. So how long? If there's a callbacks, then it's 0, because I already have callbacks to do. For example, you say, but we just processed all the callbacks, and the timeouts that had callbacks, we run them immediately. Yes, but maybe those timeouts schedule. Maybe those callbacks scheduled other callbacks. So those are pending now. So if there's callbacks to do, then we don't block at all. If there's timeouts, but no callbacks, then we block at maximum until the next timeout is due, because then we're already busy. And if there's nothing to do, then we block for an hour. This is not really 100% true, because if you use many I.O. loops, you can schedule a callback in another I.O. loop, and then you want to wake it up, so then you can send the signal to it, and then it will wake up. But unless you're doing fancy stuff, this is what will happen. And then once we know the poll timeout, then we block.
Can you explain that again?
Sure. Which part?
This slide.
This slide. Oh, very easy. Okay, so we have a list of callbacks. We have already run them all. Then we have a heap of timeouts ordered by time. We executed all the timeouts that were due now.
How does it poll for events?
Oh, it calls poll. I will show you the source. Do I need to explain more, or that already?
If you're going to go and look at the source in there.
Yeah, we'll look at the source. But yeah. Anyway, since I was explaining again, I'll just do it. Then we poll the time. If we have callbacks already to run now, then we will not block. If there's timeouts, we will walk until the next timeout, because then we know that we are already busy. And if nothing is there, then it just blocks for an hour. It's just a value picked from thin air, I think, this hour. And then we block for this time. Fourth, we process the events. For each event.
Sorry.
Oh.
You said it blocks.
Yeah.
What does that mean?
It blocks. It doesn't have anything else to do. It says, well, I run all my callbacks. I processed all my timeouts.
I'm imagining something that you say, okay, so it's polling for events means it's watching a bunch of file descriptors.
Yeah.
Sockets, some of them are maybe real files.
Yeah.
So in what sense that surely it's got to like just keep looking at them.
Yeah.
So that's not. I mean, is that blocking or is that?
Well, by this I mean if there's no event in any file descriptor, then it will just wait until there's an event. It will not be actively blocked there. It was just it's waiting for events. So it's not really doing anything.
And what does it do after an hour?
Sorry?
What does it do at the end of the 1 hour if it finds nothing?
Oh, it just will go back to the top, back to the first step. Are there callbacks? No, because I already did. Okay, nothing to do. Are there timeouts that let you know? No, not yet. Okay. Let's poll for events. So this hour, I think it could just be a very high number. I think you just put an hour just to put something there. That's my guess. Okay, process the events. So let's suppose that there are indeed some events in some health descriptor, something happened. So for each event, we just call this handler, and we go back to the beginning of the loop, as we just said. So the example, let's look at the example again. We defined some main handler that extends the request handler. I said whenever there's a get, please write hello world back. Then I define an application for the /URL, call the main handler. And please listen to this port and Mr. IO loop start. Cool. Let's look at the source of. Let's look. Let me explain before what it does. Application.listen starts the HTTP server, as we said, and it calls add accept handler, which means when there's when there's a connection accepted, please call the double underscore call of my application. So when a client connects, this will happen. It's the single most difficult slide. So when we are done with it, then you know everything. IO loop, it calls for connections. When it has some connections, it calls the TCP server, which actually is what the HTTP server is. It extends it, which it creates an HTTP connection, and this calls read. This reads using callback. So first it reads the headers, and when you're done with the headers, please call me back. And the function that is called back is the one that will read the body, and then please call back, and they call each other back. When everything is read, or enough, then it calls the request callback, which is actually the application double underscore call, as we said many times, which will parse the URL, as we said, will call request handler execute, which will call get or post or whatever, and then it writes the HTTP connection in chunks, because maybe it's not, maybe you need to write a gig of bytes, so you're not going to write it all. So that's in chunks, you will not block their writing. And if auto finish is true with underscore, then it will finish it. We will look at this auto finish thing later. Okay, so IO loop. What does the IO loop look like? This is the IO loop, the start method. Well, when I call IO loop start, this is the last line. Hello? It's haunted. Do I turn it off? Okay. Strange. The IO loop is not happy. Okay, I call start. This is the last line in my example. So it's just running to true. Well, okay. Poll timeout an hour, as we said. Okay, here this is thread safe, so you can. That's why it uses this lock. It gets the callbacks, and then it says self.callbacks to empty list. So now we took out the callbacks and we put them in a local variable in this method. So other threads can modify and kind of add callbacks to you, and it will work. For each callback, we run it, as I promised. Okay, so we've done with the callbacks. The first step. Second step, the timeouts. This is the time, so I don't have to check the time for every timeout. It's not very expensive, but then again, if we don't need it. Okay, let's look at the timeouts. While there are timeouts, if... What do I do with this? Yeah? Okay. Let's just go on. Timeouts. If the callback is none, it means it was cancelled. Oh, now it stopped. No, it didn't. I can shout, huh? Hello? Seems to be okay.
Okay.
This is Thor.
I don't know.
Okay.
Try now.
Thank you. Okay, so timeouts. I will try outside. Maybe it matches my body. Timeouts. Well, there are timeouts because timeouts are in a heap, so it will not iterate them. What it does is it pops them. It just pops all the timeouts that it has to run. So we look at the first timeout, the one that is more urgent. If it doesn't have a callback anymore, it means it was cancelled, so there's nothing to do. We just remove it from the heap. Okay, that was not our timeout then. Let's look again. The first in the heap. Is it due now? If it is, well, we pop it out of the heap and we run its callback. And if not, like yeah, there's a callback. There's a timeout, sorry, that has a callback, so it's not cancelled, but it's not due now. So I calculate how many seconds I have to wait until I have to run this timeout, and this is the poll timeout. The minimum of these seconds will be my poll timeout. And that's it. We run all the timeouts that were due now. Okay, maybe maybe this callback that I called here added more callbacks. So then clearly I have work to do, but I don't want to do it now, because maybe those callbacks add more callbacks, and then you're always running callbacks, and you're never checking for events. So if there are callbacks, poll timeout is 0, so I will first check for events, and then I will run the callbacks. Maybe somebody stopped us. Okay, then nothing to do. And here is where we poll for events. So we call poll. This impl is a, forget the name, KQ or epoll, sorry. It's the guy. You can tell it a file descriptor and some event and tell it, please wake me up or tell me when these file descriptors have something in them, something changed, somebody wrote to them, or I can write to them, and it will call you. So this is the actual guy that will do the magic of the non-blocking, and we're not going to look at that source. We trust it. Okay. So we get some event pairs, which means this file descriptor has this event on it. For example, I have this socket there, and you can read to it. And I have that other socket, and you can write. And that other one, you can read, write, and another one, there's an error, something like this. So then we update these events. Here we keep a list of a dictionary of event pairs. Right? Yeah. So for each of those events, we get the file descriptor and the events that happened on them. For example, certain socket had an exception, and somebody accepted the connection there. Or in this other file descriptor, you can read. And then we call the handler. So when I set up a handler for a certain event, that ended up here. So the handler for this file descriptor is, for example, application.double_call. So then we call it, passing it the file descriptor and the events that happen there. And that's it. And then we go back up, and we run the callbacks again, and I removed some complicated lines from the IO loop, by the way. So if you look at the source, you will find a bit more spices, but basically it's this. Because I tried to explain the whole source, and it was just too complicated. People were just losing north. So schedule tasks. How do we schedule a task? Because now I said, yeah, there's underscore callbacks, but handlers, sorry. Well, if you want to be called back as soon as possible, then you call IOLoop.addCallback. If you want to be called back later, you call @timeout. And if you would like to be called often, there's this class called periodic callback, and what it does is it schedules a timeout, and when it runs, then it schedules the next timeout, etc. Let's look at scheduled tasks. 55 minutes. Okay, this is a very strange web thing that does the following. When you connect to this website, it will not do anything. It will just wait. You will see the browser loading. And then, when somebody calls process, then you will see the response process that at some date time. So how does it work? Well, as I said, we always been doing, we create this request handler with the get. Nobody's calling the process so far. What I do is, when you connect, I take this self, which is the handler for your connection. This is your, this instance is only for you. And I append it to some list. Yes, I will explain in a minute. What it does, well, I can explain you now. It's not a secret. You remember they said at some point, yeah, and then we maybe finish the connection. We finish the connection if it's auto-finish true. Well, this sets auto-finish to false and does some other things, but basically this is what it does. So this is so that, because I want somebody to call process later, so if I finish the connection now, then the game is over. Okay. And then we define the application, and we tell it to listen. And so what is this periodic callback thing? I define a periodic callback that will call process requests every 5 seconds. And what does process requests? If they are requests, you remove from the list, and you call process on it. So what will happen is everybody will keep waiting, And until 5 seconds later, everybody gets that response. It's silly, but it shows how this periodic callback works. Okay. So how does add callback work? Well, it adds the callback to the list of callbacks. It's really that easy. And then it wraps it in a thread local stack context thing. So what do I mean thread local like? Yeah. It took me a while to half understand this thing. So it keeps track of the socket connection, and it handles the association between the socket and the application classes. So to the socket and to the application, it looks like they are alone. There's nobody else there. Even though in the behind the scenes there's lots of sockets waiting and associated to application instances. How does add callback really work? Let's see. We set the callback lock same as before, because from other threads they can schedule callbacks on you. Yeah, some thread identifier. We're not doing anything fancy. So, here we append this callback to the list of callbacks. So this is the line that does everything. The fancy stack context that I told you, it wraps the callback on it and it appends it to the list. That's it. And then, yeah, well, if we are in the YOLOPS thread, then we're not polling. So if we're not polling, then we need to wake up. So this means somebody is calling while we are waiting for events. We did all callbacks and our timeouts, and we didn't have anything to do, and then we're waiting for events. And meanwhile, from another thread, somebody calls this. So then we need to wake up. So this is what we'll do. But this is pretty fancy. I think you need this. Okay, how does add timeout work? It's really similar. Instead of a list now, it's a heap, because we are really interested in the timeout that comes sooner. And it also wraps it in the same thread local like stack context. So how does it work? Add timeout. We have a deadline and a callback, and we get an object for it that will handle these values, and we push to the heap. And its weight is the timeout. Okay, how do periodic callbacks work? It's like timeouts. Periodic callback implements 3 methods, basically. It has more, but start with which schedules the next timeout, and it tells you to call run. So this guy just says, if periodic callbacks is every 5 seconds, do this. Then start, what it will do is, in 5 seconds, call _run. And it marks the periodic callback as running. Stop, just removes the next timeout and marks it as stopped, and run calls the callback, unless that was. So I think if you had to implement it, this is how you would do it, and it would take you 3 seconds. But nevertheless, look at the source, just in case you don't believe me. The IO loop is the one of this process, unless you pass me something. We are not running yet. There's no timeouts. The callback is what you passed me, and the callback time is what you passed me. This is every 5 seconds run. This is what callback time is. Start, as I said, we set running to true, and the time for the next timeout is right now, and then we schedule the next. Yeah, because it's a bit of magic. Because schedule next, where is schedule next? Here. If we were running, then to the next timeout, which we set the current time to it, we add the next callback time. So this will be now plus 5 seconds. Because timeouts work, you need to pass the time when you want to be run. 30 minutes. Thanks. Okay, so this calculates at what time is the next run. And then we add it, we schedule, here it is, the end of the line. We call add timeout, the next timeout, and self run. What does run do? It checks if we are running. If we're not running, nothing to do. And then it calls the callback. And if there was an exception, then, well, we log it and we schedule the next. Anyway. And stop, it just sets running to false, and remove the timeout, and self timeout is none. So, again.
Why didn't you use logging.exception? You used logging.error, something that happened?
Yeah, good question. I don't know. I didn't write it myself. It's a good point, actually. So what about callback? Because I heard there's a class called capital C callback that doesn't require me to do all these things. Yes, you're right. Can I go? Async handlers, the @asynchronous, as we already explained, and the auto finish. Okay, so as I explained a minute ago, the @asynchronous just set auto finish to false, so it doesn't finish automatically at the end of the get or the post. The connection remains open, and then you have to close it yourself whenever you want. If you don't close it, it will be open forever until it times out. It also does some exception wrapping, but that's not the important thing. So, for example, this is actually an example. There's another example, which is a bit nicer, and then at the end there's a better example. Okay, we define, this is a website that tells you if it's Friday. So what I do to tell you if it's Friday is I create a client, HTTP client, and I fetch isitfriday.biz, and whenever you have data, please call on fetch. Since this will take a while and this is asynchronous, I need to mark it as asynchronous. So after this, the connection will not be closed. And whenever this page is fetched, I will get called on fetch, and then I will finish the connection and write response body. Well, first I will write whatever I got from this Is It Friday, and then I will finish. Yes? If I have more code before the fetch, indeed, yeah. So when I call fetch, then yeah, yeah, indeed, yeah, yeah. I could do more stuff underneath here. Okay, and the same as before. I don't need to explain this. Yeah. Yeah. What if you don't care about it? Maybe you just want to save a file and it's a gig. Do you need to wait for the gig? No. There's a streaming callback and it will call you by chunks of data. Let me close this guy. Oh, I don't want to print. Okay, keyboard. Fetch async. Okay, but yeah, nested callbacks. A callback and please call me back, and that callback has another callback, and it's really ugly, so I don't like that. So the uppercase callback class that I was mentioning, generators. How do I avoid these callbacks? By using callback or task. So what is this callback thing? Well, this is the code that we just seen. No, this is the bettered call. The bettered example. Fetch this, and the callback is yield callback some key. And the response is yield wait some key, and then I finish. So it looks like there's no callback here. So what it happens is, callback some key means when you get data, put it somewhere, and index it under the key some key, because I will be maybe waiting for other stuffs. So this I call some key. And wait means, please check if there's some data that somebody indexed under this name, and if there is, please return it to me. Otherwise, well, call me later when you do have that data. And then finish. So it looks more readable. There's a third version of this example, which is a bit nicer. Because some key, what do I mean some key? Some key doesn't mean anything. I don't care about that key. Why do I need to write this ugly some key? Well, turns out I don't. Yeah, it's the some key for this connection. Yeah, well, yeah. And it's also, so even if you don't use multi-threading, you still have more than one connection at the same time. You can put in the same key. So this is safe. This will work. Because this key is not for everybody. It's just for you, for your connection. I think it's associated to the socket, if I am correct. 24 minutes. Yield points. Before we understand this example and the next one, we need to know about yield points. So what is a yield point? Something you yield, and then something happens. But what is a yield point? Well, we've just seen it. Callback is, as I said, please send the result for a key. So fetch this website, and when you have the data, put it somewhere under a key. Wait is wait until the result arrives. It doesn't block, of course. It's just the IO loop will call you back when there's data there. Wait many is the same as wait, but for many keys. You can pass it a list of keys, and when all of them are there, you will be called. There's also task, which is wait and callback all together with an auto-generated key, which is what we wanted, because I didn't want to write some key there because I only have one key, and it's that one. And if I have many, I don't care. Sometimes you do care about the keys, but in this case, I didn't. And multi, which is just a list of yield points. It's exactly what it is. So, so how do we do this async processing? Well, as I explained before, this means when the result arrives, send it, store it. Maybe it would be a better verb. Store it under the key, and when the result arrives, put it in the response variable. So it's getting slow. Let's look at the source. Fetch gen. This is the code that we just seen. I think it's clear by now. We've seen it 2 or 3 times. So how would I do it without that? How would I use task? Okay. I still initialize the client, and I still have to use asynchronous. This engine thing is what makes this task and callback work. And the response is yield some task. The task is you call this function, http client.fetch, with this parameter. So that's it. Much readable. You still need to yield, but there's no escape from there. So this looks like it's not concurrent. So how do the yield points work, actually? Okay, this is the base class for yield point. They have to implement start, is ready, get result. That's what you would expect. Callback. Start is just register the callback for this key. So what this means is when I have some data, I want to be called back because I need to store it under a key. Is ready? Yeah, sure, we're ready. I'm ready to receive the data. Please give it to me. And get result is this will get the result that was stored for this key. Wait. It has the state of the key. Which key are we waiting for? This runner is the engine, is the generator engine that keeps the whole thing working. We can look at the source later. Is ready? Well, we are ready whenever the key is ready, whenever there is data there. And get result is pop the result for this key. Wait all, it does the same, but we are ready if all our keys are ready. And we get result, it pops the result for all the keys. Nothing to be done there. The task is a bit more complicated, but is what we said before. This is Tornado's way to generate a random key, just some object. It doesn't have to be a string. Register callback for the key, and runner, as I said, is the engine. When I put at engine, register the callback for this key that I made, and call func, and func is the function that you wanted to call. So, for example, http client.fetch, call the function with the args and keyword arguments that you passed me. And is ready, we are ready whenever our runner says that the key is ready, so whenever there's some data under that key. And get result is just get the result for the key, as it happened with the wait. So it's a mixture of both classes. And multi is just a list of them. So we just initialize all of them, run all of them, is ready, is true if all are ready, and get result is just get result for all of them. It's pretty clear. Websockets. Yeah.
The difference between the very first one with the explicit callback and the last one with the deal with the task.
Yes.
Will you show the difference between?
You mean the examples? Yeah, sure. Sure. It's very easy. Yeah. Okay. The one before this. Here, no. This one, the third example. Let's see. Can I get the editor? Can I get the editor then? Yes. Okay, so, yes. Yeah. Yeah, so it sets this callback behind the scenes to the generator class. Yeah. Let's look at actually it's here, right? Fetch gen. No. It's the fifth one. This one. Is this one you were referring to? So yeah, we have the task, and it's this engine, the one who sets the callback. So it's not in the code of task. It's in the code of engine, which we haven't looked at yet. I think it comes later. Yeah, that's right. It just schedules a callback for you. No. Maybe it has a return value, like success or something like this. I don't remember, but the important is the callback. Yeah. Okay. And now we enter the. So we have 18 minutes left. I will go as far as I can. Let's see. We were going to talk about WebSockets. WebSockets are really ugly. I was surprised that they are so ugly, so much complication. So if you want to use WebSockets, well, actually it's quite easy to do it with Tornado. Instead of using request handler, you use WebSocket handler, and you implement onMessage. So whenever you receive a message, this method will be called. So how do we do this? Okay, this is just some. If I open a browser here, it will say hello, and I will accept it, and then I will get another alert. You said hello, and I accept it, and it will keep replying me this message. So, okay, when it's open, I just print the WebSocket opened in my terminal, nothing there. Okay, when I receive a message, I send it back, prepending you said to it, and when I close, I just print it close in the terminal. I know this is very ugly. It's like I'm writing PHP now, mixing code and HTML. But I really wanted it all in the same place. So some JavaScript, we initiate the WebSocket to this slash WebSocket, which I define here, the echo WebSocket. So when it's opened, I send hello EuroPython to it. And when there's a message received from the WebSocket, I alert it. And I send it back, so it will keep popping messages. And I just start the application as before. This page handler is the one that renders this web page. So as you see, it's more or less the same. No big deal there. So how does it work behind the scenes? It's similar to Asynchronous because the connection is kept open. What happens is first you read, and then when you write, you read for more until something gets there, and then you write a response. And you read for more. To application, it just looks like a request handler. The application doesn't care if it has like here, if it has a page handler, which is a request handler, or if you have this echo WebSocket, which is actually a WebSocket handler. It's just a handler. It implements _execute. So good. So what does WebSocket work? As we said, it has to implement down _execute, so it quacks like a request handler. It accepts the connection, it decides the version of the protocol, and instantiates the WebSocket protocol class. Because there's several classes depending on which version are you going to use. They fight for a while, and then they decide which version it is, and then everything turns a bit more neat. So accept connection, it sends the required initial message, because it's required for the WebSocket protocol. It reads for this next message asynchronously, and then write response. It writes a response to the socket, and it reads for the next message. Also asynchronously, of course. So how does the code work? Well, I warn you that this is a bit ugly code. But I think it's not ugly because of Tornado, it's ugly because that's what it is. It's a lot of documentation. Underscore execute, as we said. We'll have again the transforms. Maybe the method is not get, then it's not allowed. If we have upgrade, this is all required for the WebSocket protocol. I will not get into detail because then we would need another hour. We care about the version, and then depending on the version, it's WebSocket protocol 13. Maybe it's draft 76. Anyway, and then write message. So we JSON encode it and we write it. WS connection, write message. So subprotocol is the one that, there's no subprotocols. This is the, there's some Star Wars effect here. Anyway, so you need to extend this WebSocket handler. That's why there's some pass methods.
Is that write message calling another write message?
Sorry? Let me look here. Write message calls write message. Yes. So write message on the handler when you do self.write message yourself. It calls write message on the connection. And what is this connection? So let's look for it. It's the where is it? I'll find it now. Self.there's connection equals none. Oh, okay, but what else is it? Because I'm sure there's something else that it is. None. WebSocket protocol 13 or 76. So depending on the protocol, you want to write. Oh, for which protocol? It's not so easy in WebSockets. So if you don't look at all the complexity for the fact of using WebSockets, yeah, maybe this is not the best example. So I will just continue with more interesting stuff. IOStream, 12 minutes. Let's see if we can get to the end of this. This is the nice part. So if you want to read some nice code, you could read this one. The IOStream is the one that handles this asynchronous writing and reading. So when you say, please read from this socket, well, this guy will read from you, and it will make sure that you're not blocked. It's asynchronous and uses IO loop callbacks. So it has this method at IO state, which you call, and then you can tell it, please notify me when I can read or I can write or when there's an error. Handle events is a method that it implements, and then it checks. In this stream that I have, can I read? Then I call handle read. If there's a handle for read, he will be called. Can I write? Then call handle write, and the same for errors. What is handle read? Well, it stores data in a read buffer, and then it calls the read callback. And read callback will call read from buffer. And handle write, it writes data from the write socket, from the write buffer into the socket, so it does some buffering. And it handles some various circumstances that you can learn if you look at the source, but it's not really important. And then it calls the write callback if it exists. So after you've written. So when you call connect on a socket, it will add itself to the state of the socket of write, because probably you want to write. Read sets the callback for reading. If there's data in the read buffer, there you go. So if you want to read from an IOStream and it already has some data in the read buffer, then it just returns it to you. If not, then it will have to wait until it can read and then call you. And when you write, it will put data in the write buffer, and then it will schedule itself for write. So whenever it can write, it will write for you. So that means that maybe you call IOStream.write, and it says, yeah, sure, no problem. And it hasn't written anything yet, and maybe the user closes the connection and he never gets it. But I think normally we don't care about that. If you care about that, then you should ask for a confirmation. So can I use IOStream directly? Yes, if you really want. Like at the beginning, we did something similar with the uppercase thing, read until there's a backslash. So you have read until regex. It will read until there's a match. Read until a certain character. Read an amount of bytes, or read until the connection is closed. And all of them take a callback. And as we said before, there's also read until close and read bytes take the streaming callback. So if you want to read a lot of bytes, or you want to read it all, you can get chunks of data instead of it all at the end. We can check how that would work. This is some example of an HTTP download. We have 9 minutes left. Okay, I create a temporary file. I set up a client like before, but I pass it a streaming callback. So I don't really need to use IOStream directly in this case. I just open a request on the HTTP client of Tornado. And then I just tell it to fetch. And what is the streaming callback? Well, just write to the file. What is this async callback? When we're done on where there's an error, then it will be called. So I will use this one to close the file or to print some error. And that's it. And let's see if we can see how it's... Nah. The code of IOStream is a bit complicated, so I will not go into it now. how do I talk to database? Because I promised you that you would talk to databases using Tornado. Well, there's, let me see, 8 minutes. This database connection, so initially you're very happy because, oh, nice, there's something there in Tornado. I can just, I call query, I pass it to MySQL. Well, okay, I can do that. And it returns an iterable. It's really nice. But if you look at the source, yeah, no problem. I open a connection, self.query, self.write. Nice, it's solved, right? Well, it's not asynchronous. So, is there anything asynchronous? Yeah, MongoDB, for example. There's something called AsyncMongo, which is an asynchronous MongoDB client. It uses the Tornado's IO loop. And you call db.find. It takes a callback parameter. So this is asynchronous. I initialize the database. I, for example, find me some guy user. And when there's a response, write found or write the name. Yeah, on delete. But what about MySQL? Well, there is something. No, sorry. Let's finish with this guy before. How does AsyncMongo work? It has something called a connection, which is kept in a connection pool. And then it sends that via the IOStream. So as we said, when you run to read or write, you just use the IOStream and it will make sure you're not blocked. So this is what it does. And since you can just send JSON back and forth, then it's really easy to write this client. I don't have the code here, but it's quite easy to read. So can we write our own async MySQL? Well, it's difficult because the C driver has some blocking calls. So MySQL query and a store result and use result, these are blocking. If you call that C code, you're not asynchronous anymore. You could implement your own binary thing like these guys did. There's some TX MySQL, which they just implement the binary protocol in Python. You just twist it. But Tornado has something called Tornado.platform.twisted, which makes it pretend like it's twisted. And they say it works. It's slower because, yeah, but you're doing all the work yourself in Python, so it's going to be slower. But they say it works. I couldn't get it to work. So maybe you will have more luck. Any questions? Yeah.
You're going to get your requests are going to block for each different client, waiting for the database to come back to you.
Yeah.
Whereas what you want is each request to kind of just fire off a MySQL request and like wait for a callback and then return.
Yeah.
Control, to the IO.
Yeah.
So if each request blocks, what does that mean? What does that mean?
Maybe it's okay for you. Maybe you always do very quick queries. And maybe you don't handle a lot of connections every second, so maybe you're okay with that. Then you're fine. But if you have a lot of connections to do, then you will be blocked for each. So while if you and me are together we and me open the same web page, and my request needs a very long query. Well, you're gonna be waiting until I am done with my query.
So when you say it blocks, that means there's nothing else. So
Yes.
no other thread can do anything. It's just this.
Indeed. If there's only one process, there's only one thread. That thread is running some query. Okay. So yeah, I mean, you could have another server that runs the queries for you and has many threads, and then it communicates using EuroMQ, for example.
What is there for asynchronously spawning a thread, waiting until that has some result, and getting that full callback?
Yeah, you can just do it. You could create a thread, and yeah, you would have to do it yourself. Actually, there's no particular support in Tornado, as far as I know, to use this. Yes.
How long did it take you to read the Tornado source code to get familiar with it?
That's a difficult question to answer. I don't remember. Yeah, that's what I did actually. I wrote this, well, at the beginning I didn't know how it works, so I wrote a very simple thing from the documentation. And then, okay, what does this do? And in the end I ended up reading the IO loop, and then when you read the IO loop, then you have already a general idea. And but it didn't take that long. Yeah. Yeah, but when you read it, you say, well, okay, what else did I expect it to do? Yeah, okay. I think maybe it's just a Python thing. It allows you to write quite to the point. Yes?
Handle errors because we only see a successful track. What happens? Those callbacks are called on success or also on error.
Also on error.
Same callback will be called on error.
Yeah, it
And probably I know the error because all your code and all your example were
Yeah.
only following the lucky path, and there was no error handling in.
you're right. I don't remember. I'm not sure if it calls it wouldn't make sense to call the callback because the callback expects some data. So I would guess that there's an error callback, but I'm not sure. I would have to check the documentation. Sorry, I don't remember. But there is something that you can do. Yes.
How much of Twisted is supported in the Tornado platform Twisted? What does it do for you?
Yeah, it's as far as I know, it's not 100% support. There's some things that work and some things that don't. But I haven't tested myself, so sorry, I can't answer this question. But yeah, you can Twisted's version of scheduling timeouts and callbacks. You can do all that, and that allegedly it works. I couldn't get it to work, but
I just wanted to say that supporting Twisted is actually quite good.
okay.
Itself from calling the function end thread.
Oh,
And the database pooling, connection pooling, all that works quite well with that. So if
Yeah.
they did that,
yeah. Maybe that's the way. Maybe that would solve the problem you had. Yes.
one more question about the multiprocessing. I saw that the loop is running in a thread, a special thread. Does it mean that if I have four cores, it will automatically create four IO loops?
No, it will only use one. There's some multiprocess module in. Yeah.
Is there any implicit support helper for multiprocessing?
Yeah, there's something, but it's very small. What it does is it's called multiprocessor, I think, and you can tell it how many processes you want. If you don't tell it, then it will look at the number of cores, and it will start that many I/O loops. But that's where it ends. So you will have to use Nginx or something else to between your many I/O loops and the internet. Myself, I only use one core. I have two processes running. One gets the control messages, and the other actually handles the clients, and I'm happy with that because yeah. Yes.
At the beginning you said you could get it to talk to Apache with Whiskey.
Yeah.
Have you done that yourself?
No. I did use it with Nginx, but it was slower than just connecting it directly to the internet. So I just did that because I didn't need any fancy stuff. I just wanted a lot of connections at the same time. More questions? Oh, now the questions begin. Yes.
Did you migrate with an existing application?
No, I started it from scratch. Yeah. Any more questions?
So there are the question earlier that you had about whether how the Twisted Tornado platform Twisted thing worked.
Yeah.
That's an implementation of the Twisted reactor.
Yeah.
Written using the Tornado I/O loop.
Mm-hmm.
So it's just an AI mapping. There's also another project called Cyclone, which
Okay.
is implementing the I/O loop in Twisted, which is the other
Okay.
project. So
Oh, I didn't know the one. Yeah.
So one might work with the other.
Yeah. Then again, maybe it's just better to just use Twisted if.
Well, if you have a Tornado app and then you want to do Twisted stuff,
Yeah.
you just do it together. So.
Yeah. Yeah. Any more questions? Thank you. Thanks a lot for bearing all this in-depth look at code. I hope it was not too boring, and I hope it engages you into reading more source code and sharing with others. Thanks.
A little bit of housekeeping for all the participants. The coffee break is at 10:30, and so We just finished a little bit in advance, so you have time to go into the other room. Thank you.
Hi.